Okay, so today we're mainly working again with tables if you guys just came in. We have two versions here where we use a y or an f of x. And the idea here is that it just helps us organize our input and our output. So if I said y is equal to 3x plus 2, okay, this is the same thing as me writing f of x is equal to 3x plus 2. And you did these problems in your last homework just yesterday, actually, well, 2 days ago. So I see about half the class went through this, and you guys did really well. So either you finished or you didn't. A lot of you guys haven't started yet, so that's going to be late. Okay, so make sure you do spend some time trying to get this done as fast as possible. Oops. Okay, so when we write these out, you can do one of two things. You can either write it out completely, or we can just write some numbers. Let's start 1, 2, 3. And I'm going to replace x with, so we can write y is equal to, but I think that's kind of redundant because y is here already. So we're just going to write 3 parentheses plus 2, 3 parentheses plus 2, 3 parentheses plus 2. This is really the fastest way to show the work. And x is 1, x is 2, x is 3. Well, does that look any different on the f of x side when x is 1, 2, 3? Actually, no. There's no difference because f of x is just 3x plus 2. Okay. But the cool thing about writing an f of x is that we write f of 1, f of 2, and f of 3, and you know what you're plugging in. Here, this is just y. So it doesn't help you identify what you're plugging in. In this case, x is now 1, x is now 2, and x is now 3. In the end, you still get the same table. And 1 becomes 3 times 1 is 3 plus 2 is 5. 3 times 2 is 6 plus 2 is 8. And 3 times 3 is 9 plus 2 is 11. Okay. Now, when this comes to a table is just a way of plotting points. We can call these ordered pairs. Call it 1, 5. When x is 1, y is 5. When x is 2, y is 8. And x is 3, y is 11. We can graph this on our table here. We'll just go 1, 2, 3. And then we'll start up here saying 5, 8, and 11. We have a line. So what if I gave you this table first? We can go backwards and write the table. X's and Y's. If X is somewhere down the points 1, 5, 2, 8, 3, 11. Well, when X is 1, Y has to be 5. When X is 2, Y has to be 8. When X is 3, Y has to be 11. So the X's are our input and our Y's are output. So the idea of these tables are just really just for organization. They're not anything special besides that it's not a special technique that helps us get the answer faster. No, we're doing all the work anyways. It just allows us to see when X is such, y becomes the result of that. Okay, so on your IXL homework day, you guys will have something that looks like, maybe it looks like a graph. Let's look at, give ourselves some points. Okay. Okay. I'm going to give you guys a table. I want you guys to fill out the table for me. So fill out the points. Okay. This will take you like 30 seconds. Okay. So when x is 0, the y is 1. When x is 2, y is 0. When x is 3, y here we said was 3. When x was 5, y is 0. Okay. Simply just filling it out. Now, there are a lot of points in between here. And this graph actually covers all the values in between the x values that we chose. And there are an infinitely many set of numbers. And this table could go on forever. It really could. And the idea of these graphs, they allow us to not have to write all these points on a table. Imagine when this last weekend when you went out of the house. So you went to a lot of places. You might have went to the market, you went to the laundry, you went to buy food. So when you tell someone what you did, you just focus on some key points. I was at the market, I was at the laundromat, I was at McDonald's, and then I came back home. You don't say, oh, at 3:01, I was on 11th Street, and then 3:02, I was on 13th Street, and 3:05, I was on 16th Street. Oh, there's a stop sign there, so I was at 30. I was at 16th Street till like 3:08. You don't do that. And that's the idea of these tables. It allows us to just throw up key points that might be important. Okay? So they're not very hard. Today's work is really based on this. Now, let's go ahead and make this a little more useful to us. Now, if I give you guys the graph f of x is equal to x squared plus 2, okay? And I ask you guys to fill out the table of the numbers -2, 1, -1, 0, 1, 2. Let's go ahead and do that. But I want you to write it this way as we first learned this. I want you to rewrite the function over and over again. Now, if you see, this table makes it nice and organized. Instead of writing it here and here and here and here, it's nice and organized so I can see my results fairly quickly. So then we write in our numbers 2, -1, 0, 1, 2. You guys ever do standards before? And you just write I, will, not. This is kind of like standards because it's really the same thing over and over again. So let's write out the math. -2 squared is +4 plus 2. -1 squared is 1 plus 2. 0 squared is 0 plus 2. 1 squared is 1 plus 2. 2 squared is 4 plus 2. We can add them. 4 plus 2 is 6. 1 plus 2 is 3. 0 plus 2 is 2. 1 plus 2 is 3. And 4 plus 2 is 6. Now, if I want to now graph it, x 0, 1, 2, negative, negative 1, negative 2. And then we can say 1, 2, 3, 4, 5, 6. We have all our ordered pairs. Negative 2 became 6. Negative 1 became 3. 0 became 2. 1 became 3. And 2 became 6. So negative 2 became 6 up here. That's 6, 4, 2. Negative 1 became 3. 0 became 2. 1 became 2. And no, 1 became 3. And then 2 became 6. We end up with a problem. Now again, these tables are helpful because it helps us organize a lot of different points. I graphed 6 points here, and I didn't cover the whole paper with a bunch of mess. I wrote it in a nice orderly manner. Because I was writing this like standards, it actually took me less time. Parentheses square, parentheses square, parentheses square, parentheses square. It took me a lot less time. And then when I plugged it in, it was nice to see what the result was. Okay. Remember, this can also be called y. F of x can also be called y. That's our output. That's our answers, our range. So I'm going to let you guys try another problem here. This time we're going to use absolute values. So f of x is equal to, let's see, 2 absolute value of x minus 2. I want you guys to use the values. Negative 2, 1, negative 1, 0, 1, 2. Okay, so go ahead and write down the problem. Do you see how I'm just leaving it blank? So go ahead and do that and then solve for the 5 points for me. Once you're done with the 5 points, go ahead and give me a nice simple graph. Okay, let's go ahead and fill out the table. Again, I would have done this repeatedly, just like standards. And then negative 2, negative 1, 0, 1, 2. Now we do the problem. Absolute value of negative 2 is a positive 2. 2 times 2 is 4. 4 minus 2. Absolute value of negative 1 is 1. That's just 1. This is just 2. 2 times 1 is 2. Minus 2. We have 2 times 0 is 0. 0 minus 2. And 2 times 1 is 2 minus 2. And 4 minus 2. In absolute values, if we know where the center is, we know we're going to repeat. 4 minus 2 is 2. 2 minus 2 is 0. 0 minus 2 is negative 2. 2 minus 2 is 0. And 4 minus 2 is 2. And now we can write this as ordered pairs, just as we're practicing this, so we're not confused about it. And these are the 5 points. We have 5 points here, right? And we can graph those on the graph over here. Negative 2, up 2, negative 1, 0. At 0, we're at negative 2. At 1, we're at 0. And at 2, we are at 2. And these are straight lines. Now, honestly, if we didn't know what absolute value graphs look like, these could be curved, right? Using these same exact values, we could kind of make a curve, maybe picture out of it. But if we plugged in more points, we could have more detail. And if we plug in more points between those, we could have more detail. But do you really want to do the work? No. The point is that if we know what the graph looks like, these absolute values are going to give us these straight line graphs, and we'll see that coming up in a couple of chapters, we'll be graphing these absolute value graphs. We can jump to a conclusion of what they look like, saving us all time. Okay, all right. Let's see what else. Besides that, I think the biggest takeaway is that f of x is really just f, and then you just plug in a number, and that's really 2 absolute value negative 2. So that for this example, this is what we would be plugging in. Okay. Now let me check if there's anything else. Oh, there's one more thing. Let me go ahead and show you guys today's IXL work. Okay, we have 3 assignments today. This one's pretty simple. If you look at this problem, it says, use the graph of the function to complete the table. Now, they gave us some points already here. I want to make sure that these make sense to you. So if I'm looking at 4, it should be 5. At 4, 1, 2, 3, 4, 5. Yeah, 4, 5. That point works. 5, 7, 5, 7. Right, that's 7. That works for me. And at 3, 3 is right here. Where would the graph be? 7. So you just write 7. So all this is you filling out a table based on the graph that they gave us already. Let's jump to the next graph. Let's see if this is any more difficult. So at 5, we have negative 4. Here's 5. Negative 4. Yeah, that works. At 2, 2 is way over here though, right? So does 2 go down? Nope, 2 is actually up here. So at 2, we have the point 2, 2. At 8, well, there's no graph down here. But the graph is actually up here. That's going to be 8, comma 2. So that's all they're having you practice, being able to read a x and y graph and plugging the points onto the table. Now, a couple things that might seem kind of weird. They use the letter G, and see how that's G. And the reason why we use a G is not F is great, but G is just another function. This is just its brother, you could say. So you can use any letter in front, F, G, H. These are our most popular letters. But the idea is that F is one function, G is another, and H is a third. They're all different functions. It's like our names aren't all the same. We're not all called Edward. So every function has a name. You can call it F, G, or H. It doesn't matter. It's just to help us tell them apart from each other. Let's look at one more here. This one looks a lot more curvy, but don't fret. Now, for this problem here, let's look at what they told us. So we have negative 8. So negative 8 is our x value right there. So the graph goes to negative 8 when y is 0. When does the graph go to negative 3? Here's negative 3. When y is also 0. See, we're sitting on the floor. And at 0, it's also going to be 0. Okay, so these problems aren't super difficult, but you want to do them as fast as you can, and then so we can get it out of our way and make sure it makes sense to you. Our next one, we're going to complete the graph based on the equation. So on your notebook, you should be writing this out, just like what they wrote. But they're going to write f of x is equal to 2x. 0, 1, 2, 3. So please write this in your notebook because you want to practice setting up these tables yourself. So we're going to write 2 parentheses, 2 parentheses, 2 parentheses, 2 parentheses. And if x is 0, we plug in 0 here. If x is 1, plug in 1. X is 2, plug in 2. X is 3, plug in 3. You want to practice this so your brain understands what the relationship is for these functions. In function notation, 2 times 0 is 0, 2 times 1 is 2, 2 times 2 is 4, and then 2 times 3 is 6. So please write out the table. You really want to do this. On the test, if you're required to show work for these problems, you're going to have to write out that table yourself. So this example of a table is what I did before. I'll teach a table. 0, 2, 4, and 6. That's what we would plug in. Okay, the problem might get a little harder. I'm going to throw some absolute values in this. So this one is going to be tougher. So for this problem, let me go ahead and set up my table again. Here's my x and f of x. Let's make that second parentheses longer. And f of x is equal to absolute value of negative x. So not a big deal, but we want to just practice. Some of you guys might know the answer already, but we're going to practice absolute value of negative, absolute value of negative, absolute value of negative, absolute value of negative. If you want, write a parentheses. Because we swapped out our x, it's like poof, it's like a cloud of smoke. Anyone ever play Pokemon Go? When a Pokemon flees, you have a cloud of smoke. The cloud of smoke was a -1, a 1, a 3, and a 5. To show work, negative and negative is a +1. Negative and a positive is a -1. Negative and a positive is a -3. Negative and a positive is a -5. And look how much work I'm showing to do this very simple idea. But I'm still showing the work because as problems get harder, you want to be able to fall back on the work that you already know how to do. 1, 1, 3, 5. 1, 1, 3, 5. And once you get good at this, we can do more mental math. But right now, I want you guys to make sure you guys know how to set it up. Okay. Now, we're going to get to our last bit here. And our last IXL is way down here. It is complete a table and graph the linear equation. So we're going to do two things in this one. We're going to, one, finish our table, and then we're going to graph the points. So we have our table, x and y, where f of x is equal to 2x. So 1, 2, 3, and 4. Then we write 2x, 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 2x. And I write the parentheses there so I can just plug in the number 1, plug in the number 2, plug in the number 3, plug in the number 4. 2 times 1 is 2, 2 times 2 is 4, 2 times 3 is 6, 2 times 4 is 8. So this is how I'm showing work. As problems get more larger, you can do this in your brain. Now, since these are ordered pairs, 1, 2, 2, 4, 3, 6, and 4, 8, you can graph these on the graph. 1, 2, x is 1, y is 2. X is 2, y is 4. X is 3, right? These are x's. Y is 6. These are y. Or functions, or f of x. They always label it on the corners. So this means in this direction, it's the x. In this direction, it's the f of x, the y. And 4, 8, 4, 8. What type of shape does that look like? It's a line. So on your IXL, what happens is that in this problem, it will actually help you graph. which is the cool thing about IXL. When IXL helps you graph, it makes it easy. We said this was 2, 4, 6, 8. So we're going to plug in points 1, 2 to put a dot on the graph. Okay, everyone see what I did there? We put a dot on the graph, just like what we practiced before. And now next point will be 2, 4. So 2, 4, put a dot on the graph. Look, it graphed it for me. Would 3, 6 be there? 3, 6? Hey, it does fit there, doesn't it? How about 4, 8? Would 4, 8 be on this graph? It is. So you really only need 2 points. Once you plug in those 2 points, you can just double check to make sure your line is correct. Okay, these problems only get slightly harder when it comes to the amount of work you have to plug in. So for this one, okay, so this is a trick question here. What if the function is just 8? Let's set up a table here. This is my last problem. If I write x and f of x and negative 8, 0, 4. Now, f of x equals to 8. There is no variable here. So I want you guys to notice this. If f of x is just 8, no parentheses, hey, isn't f of x still 8? No parentheses. Isn't f of x still 8? So this problem looks kind of funny. It's going to be negative 8, 8, and then 0, 8, and 4, 8. Aren't all these your y values? And aren't they all the same? So this likens a problem to being on a multi-floor building. I'm on the 8th floor, I'm on the 8th floor, I'm on the 8th floor. I might be walking around, but I'm still on the 8th floor. So up here, negative 8, 8 is right there, 0, 8, and 4, 8. Turns out this is a horizontal line. Why is it horizontal? Why isn't it x is 8? Because f of x, the y value, y value is 8. I don't care what x's you plug in, you're still going to be 8. Okay? I don't care what the x values are. All I care is that y is 8. So this is a horizontal line at 8. Cool. All right, that's it.